There is a widespread agreement that organizations that either design or deploy AI systems have responsibility to ensure that these systems are lawful, ethical, and technically robust. However, opinions diverge about how to best demarcate the material scope of AI governance. In fact, the lack of a clearly defined material scope remains one of the major obstacles when organizations attempt to implement AI governance in practice. Of course, there exists no one solution to the problem. Different types of AI systems pose different normative and epistemic challenges, and even similar systems can pose widely different risks depending on the applications for which they are employed. That said, pragmatic problem solving demands that every policy defines its material scope. It's an issue we cannot circumvent. Hence, in our conference paper, we review and compare previous attempts to classify AI systems for this practical purpose of operationalizing AI governance. Note that our purpose here is not to define what AI really is. Rather, it is to solve the pragmatic questions to which systems and processes ought specific governance frameworks apply. Through a systematized literature review, we find that previous attempts to classify AI systems have used one of three mental models: the switch, the ladder, and the matrix. With the switch, we refer to binary approaches according to which systems either are or are not AI systems, depending on their intrinsic characteristics. In contrast, the ladder represents technology-agnostic approaches, according to which a system is classified to the risk they pose. Finally, the matrix embodies multidimensional classifications of systems that take various aspects into account, such as input data, decision model, context, but also the use case. We go on to illustrate that these approaches are not just mental models, but also resemble real-world examples. Specifically, we show how the switch, the ladder, and the matrix resemble approaches outlined in recent publication by the IEEE, the European Commission, and the OECD, respectively. As we demonstrate in the second half of our paper, each of these models for classifying AI systems come with its own sets of strengths and weaknesses. Good classification should, of course, be fit for purpose, simple and clear, and stable over time. However, we do find that there is a three-way trade-off. For example, the switch is simple and clear and can thus be easily communicated and applied. However, classifications based on the switch are often over- or under-inclusive. The ladder, in contrast, is fit for purpose and stable over time, but it also adds complexity, which makes it difficult to implement in organizations. Finally, the matrix offers the most comprehensive model for classifying AI systems. However, classifications based on the matrix add significant upfront cost in projects and therefore add administrative burdens. What we hope is that our attempt to classify different ways of demarcating the material scope will provide policymakers but also technology providers with the conceptual tools that they need to operationalize AI governance in practice.